So the third question, I think it was not very difficult. I mean, the observation was not very difficult, but the implementation part was a bit tricky if you don't know like some STL and data structures in C++ or any other language that you use. So in this question, like we have been given an array, and that array is a permutation of numbers from 1 to n, right? And those like the numbers at each index determine or shows the power of the ith athlete, right? So if ai is greater than aj, that is the number at index I is greater than the number at index j, then the player at index I will always win in a fight with player at index j. So this is the basic idea of the question. And the order of the fights is also very important. Let me show you. For example, if this is a fight, if this is a queue, right? So this was the given array. This let me just change the order to something different. 4 uh, 3 4 2 1. This is player 1, this is player 2, this is player 3, this is player 4. So we take the first two players. Okay, we take the first two players, let us name them A and B. So if this value is smaller, that is the power of player A is smaller than power of player B, then player A will lose and player B will come at the starting of the queue, player A will go at the end of the queue, and like the middle ones will move one step forward. For example, if the fight happens between the first two players, it will be 4 2 1 3. This will be the next order after one fight, right? So the next thing, if what happens if this was 4 and this was 3, in this case player A would have higher power, so player A would remain at its place and it will be 4 2 1 3. The thing will be the same because the player at the with the higher power remains at the first position and the player with the lower power goes to the end of the queue. So this is the overall question that is being said. Now there are k queries. This is what we have been given as input, and this is what we have been explained about the process of the matches. Now we have been given k queries such that we have to answer what will be the number of wins of the ith player. For example, this is the ith player 2. What will be the number of wins for player 2 after let's say x matches, right? So if player 2 is there after x matches, how many matches it will win after x total number of matches. X total number of matches means x number of matches from the start, right? From the start, what we do, we take the first two players, keep the loser at the end and keep the winner at the first. We keep on doing this, and after x matches we have to tell how many times will the player at index 2 will win, right? So this is the question. So we have to make some clear observations here, and these observations will really help us to do this question. So let me write them down. So observation, important observation number 1 is, if there is player, let's say there is player with power 3 and there is a player with power 4. So whenever, in any case, if there is a player with higher power placed to the left of a player with lower power, like in this scenario, there might be some players here, there might be some players here, there might be some players here, but if 4 or any number greater than 3 is placed to the left of 3, then this particular player will win 0 matches. I'll write it down. If a of I is greater than a of j, such that I is less than j, then the result for j will always be 0. In any case, he will not win a single match, because for example, or some players might because for example, uh, any number of matches happen, there will be one match when it will be like this, 4 or 3, or this can be any number greater than 3, 5 or 3, then 3 will never win match from this player. So if this is true, if there is a greater number present to a number to the left of it, then the result for that number will always be 0. So this is the first observation. The second observation is the result for the maximum number will all can be infinity. So what I am storing in the result array, I am storing the maximum number of matches it can win. So in the first case we found out that this particular player J can win at max 0 matches. It cannot even win a single match. And we can say that the result for N, the player with the highest power, N can be the highest power. So this player can win a maximum of infinity matches. So it can win any number of matches, right? This is the maximum number of matches it can win. And for any number I other than N, I'll show you something that, for example, if this is 3 and there are some players here and this is any number greater than 3, X, right? So the number of matches, and we are assuming that all the numbers to the left of 3 are smaller than 3, because if it is greater than 3 then the result will always be 0. Now we have we have a scenario where all the players to the left of it are smaller than 3. Some players to the right of 3 might be bigger than 3 and might be smaller than 3. So in this particular scenario, the result of this scene will always be 1 plus. 1 means whenever there are some players, at least some players to the left of it. If there are 0 players, then this 1 will not be there. So for example, let us denote it as A, that there are A players to the left of it. So if A is there, then the result is 1. Result of I is 1. Otherwise, the result of I is 0. Right? If there are some players, then it will be 1. Right? Now we have to count the number of players to the right of 3 or any number to the right of it and to the left of the closest greater number than 3. Now this might be a little complex information to process, but this X can be any number from 4 to N. Right? So this X can be any number from 4 to N, and these can be any numbers from 1 to 3. Right? So we have to basically count these numbers, how many numbers are present between 3 and X, and X is any number from 4 to N. So X is the closest number to 3 index wise, closest number to 3 and to the right of 3 such that it is greater than 3. Right? So let us denote this number by count. So we will add count to result. So result plus is equals to count. So these are all the observations in our question, and this will really help us to find the answer. So what we have found till now, this is not the final answer, but these are the maximum number of wins that any player can have. These will be the maximum number of wins, right? So the question arises is how to find this result array, how to find all the values. So like the implementation part is what was a little bit tricky, and the observations were easy to make, but let me just now come to the implementation. So how I did it was with the help of a priority queue. Let me take an example from the question itself now. So for example, 1 2 3 5 4, this is our input array. We have 1 2 3 5 4, right? Now we start from the 0th index and we go have indexed it as 0. So we start from the 0th index, and what we do is we save the position of this particular element. So the elements will be from 1 to 5 only, or from 1 to n. So I can use a array or a vector. So for example, I have a indexes vector, and the index of 1 would be 0, and right now I have 1 in my priority queue. So while using priority queue, I will create a mini heap and the element at the top will be the minimum element. So I have sorted them in ascending order. I am using a min heap. So right now when first of all I just push this element into the queue, priority queue, and save its index, right? Now I'll start the loop from the second element. Now if I go to the second element, what I will do is I will remove all the elements from the priority queue which are smaller than this particular element, this element. So 1 is smaller than 2, so I will remove it from the priority queue, and I will set 0 to the index of 1. For example, I will save the result of indexes of 1 is equals to 0, because there are actually 0 elements present in between them, right? There are 0 elements present between them, so the result of indexes of 1 would be 0, and I'll remove this from priority queue. Now I will set the index of indexes of 2 as 1, and I'll insert 2 into the priority queue, right? Now moving on to the next index, when I come here, I see that 2 is smaller than 3. I remove it from the priority queue again, and I'll set result of result of indexes of 2 as 0. Why? Because there are actually 0 number of elements present between 2 and 3. This was one of the observations. This was actually a part of the third observation, in which we said that there are, like, as you can see, 0 number of elements present between 2 and 3. 3 lies to the right of 2, and there are 0 elements present here, right? So we can set it as 0. Again, it is done. Now we remove 2 from the queue, and we set indexes of 3 as 2. Now we push 3 into the queue. Again for 5 we do the same thing. Now uh, result of 3 would be 0. Result of index of 3 would be 0. It means, and 3 will be removed from the queue. Again 5 will be inserted to the queue. Now this is the case. Till 5 it was all same. Now this will be a little different case. In this case, what we can do is, we will see that there is an element in the priority queue that is greater than the current element, right? 5 is greater than 4, so we will directly set the result of uh, current index, that is 4. Current index, we can set it as 0, because there is an element to the left of 5, to the left of 4, that is greater than 4, right? So we can set it as 0, or you can specially mark them as -1. While solving the question, I mark them as -1, but putting them 0 is equally the same. It will not make any difference, right? So the result of 4 means this particular index 4 will be equal to 0. Why? Because there is an element which is greater than 4, and it lies to the left of 4, right? And now this time we will not remove it from the priority queue, we just need to save it, right? And the result for 5, because it is the greatest element, it will always be infinity. Now let me take just a little bit different example to show you one more use case where there is 3, 1, 2. So in this case, when I am at index 0, 1, 2, when I am at index 2, in the priority queue I will have 1 and 3. Let me just change this. 3, let this be 2, right? When I'm at index 2, in the priority queue I'll have 1 and 2, and for 3 what I'll do is I'll go to this particular index and set the result as 1. Like, if you remember, we were adding it to the result, that these are the number of elements. There is only one element between 2 and 3, so we will add result of 0, result of, or you can say result of indexes of 2 plus is equals to 1. So we will add 1 to it, because there is one element present between 2 and 3. So this was one more use case which I wanted to explain, and this is a part of the observation 2. Observation 2. This is a part of the observation 2 that we made. So this was all about this particular question. Now I'll quickly show you the code how I did it. So I've just taken n and k as the input, and I've stored all the inputs in a vector. Now I've initialized another vector. So this was the result array. The name is gg here, and I've initialized all the values with infinity initially. I've taken priority queue with min heap, so that is why it is greater than, and vector int I've taken it like this, and I've created a vector m which will store the index of every element. And initially I have pushed both pushed the 0th element at the queue, and I've set the index of v of 0 as 0. Right, now I'll start from index 1 and go till n. While there are some elements in the queue, what I'll do is I'll store the top element of the queue in a variable it. So if it is less than v of I, what I'll do is I'll set the result of the it. What is it? It is an element smaller than v of I, and m stores the index of it. So the result of uh, the element it would be equal to I minus m of it minus 1. So what is this? I minus m of it minus 1. This will be the number of elements present between these two. So in this case, this is it. So this is it. It will be here 2. M of it is the index of 2, that is 0, and I is the current index, that is 2. Right. So I have done what I have done is I minus m of it minus 1. So it means 2 minus 0 minus 1. These are the number of elements present between 2 and 3. And what is 3? 3 is the element just greater than 2 and closest to 2 in terms of indexes. Right. So there are 1 elements present between these two. So I'll set the result at this particular number, and I'll remove the element from the priority queue. If it is not present, I have set it as minus 1, the result. You can also do it as 0. This will work the same. I'll show you later how this will work the same. But you can set it as minus 1 or 0, anyone you like. Right. So if gg of I is not equal to minus 1, this means because since for this particular index there is an element present to the left of it, a greater element present to the left of it, the answer for this particular index should never change. Right. So I'll never push it to the queue. I'll only push the current element to the queue if the result is not equal to minus 1. Right. So I'll do this, and I'll store the index of the current element like this. Now I'll take in the queries, and I have subtracted 1 from A just to make it 0 based indexing. So as you can see, I have taken gg of A or result of A as minus 1. If it is equal to minus 1, I am simply printing 0. So even if it was not there, it was 0, then as you can see I have taken the minimum element. So the minimum would always be 0. So it would have eventually boiled down to like the same result. So what I am doing is I am setting the result as 0. Now if B is greater than equal to A, now this is also one more important observation, like there will be B matches, right? So for example, there are four players, 1 2 3 4. So the and their indexes are 0 1 2 3. The first match will happen between these two players. The second match will happen between the winner and the third player. So as you can see, uh, B, that is the number of matches if it is less than A. Like in this case, the number of matches were 2. So the third player or the player at index 3, that is the fourth player, that is at index 3, was never involved in the match. Right. So if B is less than A, the result will be 0. So we will only calculate the result if B is greater than equal to A. Right. So we will only calculate the result in this way. Now if A, why I am doing this? If A, then I am adding 1 to the result. If A means if A is not equal to 0. because if a is equal to 0, there will be no one on the left of a, right? If you remember, I explained it in this third observation, that there must be some elements to the left of a, then we will add 1 to the result. Here, if there are some elements to the left of this particular element, that is if a, then I'll add, then result is 1, otherwise result is 0. That is exactly what I'm doing. This I'm setting the result as 1 if a is greater than 0, that is if there are some elements to the left of the current element. Now I'm subtracting b from a. I am subtracting this, uh, in after b matches, what will happen after b matches, this particular element will reach the first position, right? This particular element will reach the first position, and there will be some elements to the right of it, and there might be some element greater than to the right of it. So we have already stored how many elements smaller than 4 are to the right of it. This was the max answer, so we will consider this particular answer, right? We will add b, that is the remaining number of matches, and gg of a, which means the maximum number of more matches it can win, that is the number of smaller elements present to the right of it, right? So b, after subtracting a from b, after subtracting a, b would be the first element in the queue, right? And it will win, let it be x, so it will win minimum of x comma b matches, right? So we will add it to the result and we will just print the result. So this was all about the third question, and I hope you were able to understand it. The third question was a bit tricky in terms of implementation, but I feel the observation was not very difficult, and I hope now you will be able to do it. I hope you enjoyed the video. Keep watching for upcoming videos. Drop a like and please subscribe. Thank you.